Today's lesson is on the product of powers. So one piece of vocabulary is something called a monomial. What this is an algebraic expression that's either a constant, which is like 1, 2, 3, a variable, x, y, z, or the product of a constant and one or more variables. So x, 2x, 5x squared, something like that, 5mn, something like that. So these properties, these power properties, when multiplying powers, whoopee daisy, when multiplying powers with the same base, you're going to keep the base and then add the exponents. What I really like about these next coming lessons is that this stuff, it really actually makes sense why this property works. So think about if you have 6 to the third times 6 to the second. This product of powers property states all I have to do is add my two exponents. If my base is the same, 6, I simply have to say, oh, okay, well, it's 6 to the 3 plus 2, which is equal to 6 to the fifth power. The reason why I like this and why it actually really seems to work is that if you have 6 to the third, that means you're going to take 6 times 6 times 6, and then multiply that by 6 to the second, which is another 6 times 6. You'll see you have 5 6s here. So this property makes it a little easier to multiply powers when you have the same base. All you do is take a look at it and add their exponents. So if you took 6 to the fifth and actually figured it out, it's going to be 7,776. So in the next one, when you just have that variable raised to that power, same concept applies. So if you have n to the fifth times n to the seventh, is the same thing as saying I'm going to take n to the 5 plus 7, okay, which is n to the 12th. You have 5 n's here, 7 more n's here, so 5 and 7 make 12 different n's, or 12 n's. So in this next one, if you have x to the 8th times x to the 3rd, same base, everything like that, add your exponents. It becomes x to the 8 plus 3, which is the same thing as x to the 11th power. You got 8 x's here, 3 more x's, grand total of 11 x's. Number 4 is one of my favorite ones because kids kind of forget about this guy right here. A lot of students will tell me that it's y to the 6th, but you have y to the 4th, you have a y to the 2nd, and then you have a y to the first power. Anything, any y or variable by itself is always to the first power. If you just have the number 2, that's to the first power. So you have to make sure you remember that little guy. So this is actually going to be y to the 7th. Yep, 7th. So these next two are pretty straightforward. M to the 5th times m to the 5th is going to be m to the 5 plus 5, which is m to the 10th. This one here is t, and then you're going to add your exponent. So it's literally going to stay as t to the x plus y. You can't simplify anything. There's nothing there to simplify. So this next piece then takes it a little bit further. It says, all right, well, I have 5 to the 4th, but I'm going to raise that whole quantity to the 2nd power. So when you raise a power to a power, you're going to keep your base and multiply your exponents. Because if you see this, y to the 4th to the 2nd is saying, oh, okay, it's going to be the same thing as 5 to the 4 times 2, which is 5 to the 8th. Okay? The reason this works is you have 5 to the 4th times 5 to the 4th. I'm taking that value that's inside there and raising it to the 2nd power. So this now goes back, if you have 5 to the 4th times 5 to the 4th, it now goes back to this concept up here, saying, oh, okay, so that's 5 to the 4 plus 4, which is 5 to the 8th. So the easier way to do this, the more efficient way to do this is to say, all right, if I have a value raised to an exponent and then I'm raising that to another power, all I have to do is multiply my exponents. So number 8 is going to be x to the 3rd times 5, which is going to be x to the 15th. Because if you think about it here, you have x to the 3rd times x to the 3rd times x to the 3rd. You're going to have 5 of those. So if you just add your exponents there, 3 plus 3 plus 3 plus 3 plus 3, it's going to give you that 15. So the easy way to do it, like I said, was to just multiply those. So then in number 9, it's going to be r to the 8 times 6, which is the same thing as r to the 48th. So this last piece now kind of puts it all together. These first two examples are pretty straightforward, the same as the raising a power to a power, so multiplying your exponents. So if you have x to the third to the fourth, you're going to take x to the 3 times 4, which is going to give you x to the 12th. If you've got t to the 6 to the third, t to the 6 times 3, which is going to be t to the 18th. So what this next piece says, though, is like when you raise a product to a power, find the power of each factor. It's almost, I call it kind of like a distributive property. In number 12 here, you have 3a to the 5th squared, meaning what this looks like is you're going to take 3 to the 5th times 3a to the 5th. Whoop. So what you're going to do is you're actually going to almost distribute that squared to each piece inside there, okay? Because you can see here you have 3 squared, okay? So when you use I always forget its name, power of a product property, when you have that, you can just take and distribute that value. So here you have 3 squared, because it's 3 to the second, times a to the 5 times 2, which is going to be 9a to the 10th. And you can see that right here. When I wrote it out like that, you have 3 times a to the 5th times 3 times a to the 5th. 3 times 3 gives you that 9. A to the 5th times a to the 5th gives you that a to the 10th. So in number 13, I'm going to write it as almost that distributive property. So when you have 1/3 to the 4th times p to the 3 times 4, 1/3 to the 4th power is the same thing as saying, oh, okay, let me take 1/3 times 1/3 times 1/3 times 1/3, which is going to give you 1/81. And then times p to the 3 times 4, which is going to give you that p to the 12th. So you have 3 different properties here. You've got this first one, which is the product of powers property, which states if you are multiplying powers with the same base, keep your base, add your exponents. You have the power of a power property, which means when you're raising a power to a power, keep the base, multiply your exponents. And then you have a power of product property, which when raising a product to a power, find the power of each factor. It's almost like distributing that exponent to each piece.